Remember, we're always going to have t's on this side and s's on this side. Okay, let's do the Laplace transform of, oh, I don't know, sine of kt. By definition, that's the integral from 0 to infinity, e to the negative st times whatever is in here, sine of kt dt. This is one of those ones where you got to use integration by parts twice. You probably remember this problem from Calc 2. I'm not going to go through all the trouble of writing out the integration by parts. I'm basically just going to jump straight to the answer. But this is a good one to try at home. You should work out all the details on this. This will be k over s squared minus k squared over s squared times the Laplace transform sine of kt. This is one of those ones where you do it twice and you end up with the same thing again. So you pull this guy over to the other side and you have two of them, or you have one plus this. Divide through a whole bunch of algebra here. We end up with this formula. And using a similar method, we could show that the Laplace transform of cosine of kt is s over s squared plus k squared. Now, most of the time when we're using Laplace transforms, like we're proving a bunch of formula right now. Most of the time we're going to be going backwards. Most of the time we'll have something that looks like this and we'll be going backwards to match something over here. So the takeaway I want you to have right now is if you've got an s on top, you've got a cosine. If you don't have an s on top, you've got a sine. So for example, let's say we had capital Y of s equals 3 over s squared plus 9. And I wanted to go backwards. I wanted to take the inverse Laplace transform of both sides. Then I would look in a table and say, okay, who does this match with? Oh, that matches with this guy where k is 3. So the inverse Laplace transform here, it matches with this one, will be sine of 3t. And the inverse Laplace transform of capital Y would be little y. If I had something that looked like this, where I've got, that's an S here, and this is a 5. This matches this formula. I've got the s squared plus 5 squared here, but I don't have a 5 on top, I've got an s. So this is going to be a cosine. So I would make this match this formula, and I would go, well, I just want the s up there, I don't want the 6. I would say this is 6 times the Laplace transform of cosine 5t, which is that.